waves, and specifically sine waves, can take on several different kinds of properties. Let's talk about those. The first one is amplitude. That's simply how much power is behind that wave. Here's a low amplitude. This would be maybe a soft sound if you were listening to a sound wave. And this would be a loud sound here if you were listening to a sound wave. Frequency. Frequency has, if you're listening to this wave, this would be the pitch. So we have a low pitch here and a high pitch. When you double this, you get 1 octave higher, which is kind of an interesting thing. So the frequency is a second property. The wavelength is a third property, and you notice that the wavelength, this is the exact same set of waves that I had in the previous slide. So you'll notice that when I have a low frequency wave, I have a long wavelength. And when I have a high frequency wave, I have a short wavelength. And so these are just inverse relationships to each other. Low frequency, high wavelength, high frequency, low wavelength. Phase is a little harder to describe. Phase is the state of a wave either relative to a given period of time or relative to another wave. So here, let's just take one of these. Here, I'll take this 180 degrees here. This wave here is at, let's see, this is at 90 degrees up here. This is 90 degrees. This one's at 180. So this one's the 0. So we're halfway through. In other words, we've done the positive but not the negative. So they are at different places in the wave. Now I can pit two waves against each other in order to create phase, or I can just say, well, relative to some starting time, when does that wave start? And that's how I determine phase. That's it for the properties of a sine wave.